Welcome to this explainer. Today, we are going on an absolutely unbelievable journey from the very first millisecond of time all the way to the frozen demise of the cosmos. As you'll see, you, the world around you, and literally every drop of water on Earth are the exact byproducts of this incredibly violent history. Let's explore this together, because we're tracing the ultimate origin story.
Here is our roadmap for today. 1. Birth of the universe. 2. Forging Earth and the Moon. 3. The ingredients for life. 4. Cosmic threats to Earth. And 5. The end of everything. Okay, let's just dive right into this sweeping epic of existence. Section 1. Birth of the universe. We're winding the cosmic videotape backward 13.7 billion years to the ultimate open question. Okay, so back in 1929, the conventional wisdom was that our universe was just kind of static. But then Edwin Hubble proved the universe is actually expanding. Galaxies are rushing away from us, and the further they are, the faster they move. If you hit rewind on that expansion, it means the entire cosmos must have started from a single, unimaginably hot, dense dot.
But that brings up the ultimate brain breaker, right? How exactly does something come from nothing? To answer this, we have to look at empty space itself. And it turns out empty space isn't actually empty at all. It's this writhing sea, a quantum vacuum washed with charged particles spontaneously popping in and out of existence. Physicists believe that randomly, without any outside input, this vacuum could generate enough energy to spark something out of absolutely nothing. A spark we now call the Big Bang.
But hold on. Early on, there was a bit of a problem. The universe is incredibly vast and surprisingly flat, which normal expansion just couldn't explain. So the crucial missing piece here is Alan Gut's inflation theory. To push all this newborn matter outwards evenly, the universe essentially went from a toddler to a teenager in the single tick of a clock.
To put that into perspective, what's really incredible about this number is the sheer scale of that growth spurt. In a millionth of a millionth of a millionth of a second, the universe multiplied its size by a 1 with 50 zeros behind it. 50! This rapid inflation spread matter out perfectly evenly, setting the stage for everything that was to come.
Moving on to Section 2, Forging Earth and the Moon.
Fast forward to about 4.5 billion years ago. The early solar system was basically a giant, brutal demolition derby known as the Titanomachy. During this chaos, a Mars-sized planet named Theia struck Earth in a catastrophic glancing blow. The sheer force of it reduced our planet to a 600-mile-deep magma ocean. But here's the amazing part. The resulting orbital debris coalesced into our massive moon. That satellite is absolutely crucial because it stabilized Earth's tilt, giving us the regular seasons that biology desperately depends on. Without it, we for sure wouldn't be here.
Section 3. The ingredients for life. Let's see how this cooling rock builds into a place that can actually support biology. Now, our newly formed Earth was totally bone dry. Yet today, we have something like 320 million cubic miles of water just sloshing around. This sparked one of the greatest cold cases in science. How did all this water get here? For a long time, scientists assumed icy comets from the outer solar system delivered it, but the chemistry just didn't add up. So, by comparing the chemical flavors of water, scientists eventually cracked the case. You see, comet ice has way too much deuterium, basically heavy water, to match Earth's oceans. So they looked closer to home, at the asteroid belt. Now, asteroids might look like totally dry rocks, but testing on meteorites and the asteroid Vesta revealed a perfect chemical match. Heat from the late heavy bombardment literally baked chemically bound water right out of these dry-looking rocks.
All right, so with vast oceans finally in place, life just needed a spark. And scientists discovered the perfect incubator sitting right at the bottom of the sea, alkaline vents. These warm, deep-sea chimneys had microscopic pores the exact size of primitive cells. Plus, they had a constant flow of chemical energy passing through them that acted exactly like an early metabolism. Chemistry literally transitioned into biology right inside these towering seafloor crucibles.
Section 4. Cosmic threats to Earth. We are not as safe in our cosmic neighborhood as you might think.
You know, surviving in this universe is pretty much against all odds. Take a look at this. 440 million years ago, a massive extinction event completely wiped out 85% of all life on Earth. And this sudden wipeout wasn't your standard climate event or an asteroid strike. The evidence points to a direct hit from a deep space death ray, specifically a gamma-ray burst.
Let's break down how this apocalypse happens. A gamma-ray burst is literally the birth cry of a black hole. When a massive star collapses, enormous magnetic forces fling matter outwards, releasing the energy equivalent of our sun's entire lifespan in mere seconds. And get this, we are currently staring down the barrel of an unstable star system called WR104, just 8,000 light-years away. If it fired a burst in our direction, it would strip our ozone layer before we even knew what hit us.
But hey, beyond external lasers, we've got internal threats to worry about too. What actually protects us from everyday cosmic radiation is our magnetic shield. To see exactly what happens when a planet loses that vital defense mechanism, we just have to look next door at Mars. Mars lost its magnetic field, and subsequently, its atmosphere was completely stripped away by solar winds, leaving it cold and barren. Our own field is currently weakening and shifting. Though scientists do believe it's just part of a natural flipping cycle, not a terminal decline, still, it really highlights just how fragile our little oasis is.
And that brings us to Section 5, the end of everything.
Because everything that has a beginning must have an end, right? For decades, scientists argued over whether the universe would collapse back in on itself in a big crunch or tear itself to absolute shreds in a big rip. But the Planck satellite mapped the early universe and showed us that dark energy, this mysterious invisible rocket fuel accelerating the expansion of space, is actually increasing steadily alongside that expansion. This rules out a crunch or a rip and points definitively to a single, cold fate.
If we trace this timeline forward, the end is actually incredibly quiet. Dark energy is just going to keep pushing galaxies further and further apart. Eventually, our sun will swell into a massive fireball 200 times its size and die. And over the next 100 trillion years, the remaining massive stars will simply run out of gas, they'll fade away, and eventually leave behind nothing but an endlessly expanding, pitch-black, frozen void.
And that really wraps up our explainer for today. Knowing that literally every single drop of water in your body, the iron in your blood, and the ground beneath your feet comes from this violently, breathtaking, fleeting cosmic history, I want to leave you with this final, provocative thought to explore on your own. In a universe bound to eventually freeze into absolute nothingness, what will we make of our brief, brilliant moment in the light? Thank you so much for joining me. Keep asking questions, and I'll see you next time.